A brief overview to rocket science. What is rocket science? Rocket science is the study of how to launch objects into space. It is a complex and challenging field that requires a deep understanding of physics, chemistry, and engineering. Rockets work by expelling hot gases out of the back of the rocket. This creates thrust, which pushes the rocket forward. The first rockets were invented in China over 1,000 years ago. They were used for fireworks and military purposes. The first rocket to reach space was launched by Germany in 1942. It was called the V-2 rocket. Today, rockets are used to launch satellites, spacecraft, and even people into space. They are also used for military purposes, such as launching missiles. There are many different types of rockets, each with its own strengths and weaknesses. Solid fuel rockets. A solid fuel rocket is like a giant space firework. Inside the rocket, there's a special kind of fuel that's already packed tightly together. When we light the fuse, the fuel burns from the inside out, creating lots of hot gas. This gas rushes out of the rocket's tail, pushing it forward like a super speedy jet. It's like a controlled explosion that helps the rocket zoom into space. Liquid fuel rockets. Imagine a liquid fuel rocket as a high-tech water gun for space. Instead of water, it has two special liquids. One is the fuel, and the other is the stuff that helps the fuel burn. These liquids are stored in separate tanks inside the rocket. When we want to launch, the liquids mix together and make a powerful fire. This fire shoots out of the rocket's back, just like water from a water gun, but super hot. This powerful stream of fire pushes the rocket upwards and into space. Hybrid rockets. Imagine a hybrid rocket like a mix between two things, a fire-breathing dragon and a water hose. Instead of using just solid fuel or liquid fuel, a hybrid rocket uses a combination of both. One part of the rocket uses solid fuel, like a dragon's fiery breath, and the other part uses liquid oxidizer, like a powerful water hose. When we want to launch, we light up the solid fuel part, and it burns just like a fire-breathing dragon. At the same time, we spray in the liquid oxidizer, which helps the fire burn even hotter. This powerful combo of burning solid fuel and liquid oxidizer creates a lot of hot gas. And just like a dragon's fiery breath can push things, this gas shoots out of the rocket, pushing it upward into space. The design of a rocket is complex and must take into account many factors, such as the weight of the payload, the desired thrust, and the environment in which the rocket will be operating. The construction of a rocket is also a complex process that requires precision and attention to detail. Any mistakes can have catastrophic consequences. The launch of a rocket is a critical event that must be carefully planned and executed. Even the slightest deviation from the plan can result in failure. Here are some additional unique facts about rocket science. The first liquid fuel rocket was invented by Robert Goddard in 1926.
After further refining the engine, Goddard was ready for its first flight. On March 16, 1926, he set up his rocket, which he later called Nell, fueled with gasoline and liquid oxygen, on a farm in Auburn, Massachusetts.
The largest rocket ever built was the Saturn V rocket, which was used to launch the Apollo spacecraft to the moon. The fastest rocket ever built was the Space Shuttle, which could reach a speed of over 17,500 miles per hour. The most powerful rocket engine ever built was the Soviet RD-170 engine, which could produce over 7.9 million pounds of thrust. The first commercial rocket launch was made by Space Exploration Technologies, SpaceX, in 2008. The first private person to travel to space was Denis Tito, who flew on a Russian Soyuz spacecraft in 2001. Relevant informations! 1. Newton's third law. Rockets work based on Newton's third law of motion. For every action, there is an equal and opposite reaction. So when a rocket expels gas out of its engine at high speeds, it pushes the rocket forward. 2. Propellant combustion. Rockets burn a mixture of fuel and oxidizer, creating a high-speed stream of hot gases. This gas is forced out of the rocket's engine nozzle, propelling the rocket forward. 3. Escape velocity to break free from Earth's gravity. A rocket needs to reach a speed called escape velocity, which is about 25,000 miles per hour, 40,000 kilometers per hour. This speed allows the rocket to overcome Earth's pull. 4. Orbital mechanics. Achieving orbit means reaching a speed where a rocket is falling towards Earth but keeps missing it. It's like a continuous free fall around the planet. This requires not just speed but also a specific direction. 5. Multi-stage design. Rockets often have multiple stages. Each stage has its own engines and fuel tanks. As a stage runs out of fuel, it's discarded to reduce weight and increase efficiency. 6. Payload and payload fairing. Payload is what the rocket carries, like satellites or astronauts. The payload fairing is the protective shell around the payload. It's jettisoned once the rocket is high enough and no longer needs the aerodynamic protection. 7. Orbital maneuvers. Changing orbits or getting to other planets involves precise maneuvers. A small burn of the engines at the right time can lead to a big change in trajectory.
8. Astrodynamics. This is like the GPS for spacecraft. It involves calculating where a spacecraft should be at a given time and how to get it there accurately using gravity assists or burns.
9. Reusability. SpaceX's innovation lies in making rockets reusable. This dramatically reduces the cost of space travel, making it more accessible. 10. Deep space travel. Rockets that go beyond our moon face challenges like long-duration space travel, radiation exposure, and life support systems for astronauts. 11. Interplanetary missions. Rockets have been used to send probes to other planets. For example, the Mars rovers have helped us learn more about the red planet's geology and potential habitability. 12. Future of rocketry. Advancements in materials, propulsion technologies like ion drives, and even concepts like the space elevator could revolutionize space travel in the future.
Thank you, Prof.